Hello friends, in this module we will see the application of R on Cox proportional modeling and inference. The Cox proportional modeling, also known as PH model, is most widely used model in analyzing event time data. Its statistical procedure for making inference about the association between the event time and covariates are well developed and theoretically justified by a matrilineal. Anderson's and Gill's on this aspect, the paper is there in 1982. For prediction using Cox model, Van Houselingen and Putter provided an excellent review for various prediction methods in clinical setting. Other recent development in this area involves high dimensional data in which the number of observation is much smaller than the number of variable. For typical study analysis is a vast majority utilizes all observation in the same data set for modeling building purposes, despite a growing literature on false positive findings. In this module, we will check the application of Cox proportional modeling on small data set through R. In this module, we are going for estimations and inference for Cox proportional model 1 using R. End of this module, we will see how to fit Cox proportional hazard regression model using R, how to get estimation using R on survival data, and prediction about survival for a specific years old of its patients. Now come to the data, is survival data taken from the head and neck cancer trial of Patil et al. In 2015. This is a partial data set used in this illustration purpose on this module. Here FU is the survival or censoring time of the patients. FU stat is standing for censoring status, 1 is standing for censored and 0 stand for not censored. Age of this patient is considered here, 6. Gender of this patient is considered as 1 for male and 0 for female. Performance status considered as PS, and type of treatment given, that is 0 is represent for cetuximab and 1 for methotrexate arm. Now, we will formulate these our objective with this intention, that what is the influence of covariates on survival duration. So, our code to read the data, here we are calling R with arm and the represents that the first individuals treated with cetuximab, second with methotrexate, third one again cetuximab, fourth, fifth, sixth patient treated with methotrexate, like that. So, what patient, the first, second, third onwards patient, which patient treating which treatment, coded as 0 and 1 here. Now, coming to the second variable, that is FU time, again these survival or censoring time observed for each patients are given here as a FU time. You can see minimum value in this observation is 19. So, minimum follow of patients is 19 days, whereas maximum observations, maximum value of here is obtained as 257. So, maximum duration followed for a patient is 257. Now, some of them had censored, some of them has not censored. So, if they are censored, it is given as 1, if they not, it is given as 0. So, here you can see 3 event occurred, that is given as 0, 0, 0, and rest of them censored observations. Male patients were coded as 1 and female coded as 0. It should be 0, not 2 for female patients, and the age of these patients are considered as 25 years, 32 years, 42 years, 23 years, like that. So, and the PS status is considered as 2, 3, 4, 2, 1, 4, 3 of each patients, and chemo is considered to assign this variable name, that is FU time, FU stat, sex, age and PS, through the function called data.frame. Now we are calling summary of chemo to get the basic descriptive statistics about the data. So this is the basic statistics about the data, that arm is having minimum observation 0, since we have considered only 1 and 2. So if in case of arm, these values are maximum value 1 and 0. So in case of maximum value for arm is coming 1. For follow-up observations, minimum follow-up observations is given as 19 and maximum to 57 days. Again, this since the status is having dichotomous variable, so there is not any meaning to see this mean value here. Again, the 6 also considered as a dichotomous variable, so again it's not meaning to take this mean and minimum value, because we know the minimum value was given as 1 and maximum 2. And again, age is having 23 to 74 years. So minimum patient's age was 23 years and maximum patient age was 74 years, and performance status is given as 1 to 4. Now we are going for our code to generate the Coxs proportional hazard modeling with covariates. Here, before that, we have to load the library that is called library survival. In that library survival, our package function Coxs PH will work. When we are calling with Coxs PH, within parentheses we have to call the function surv. Into that we have to call that fu time and fu stat, and this factor of right hand side need to be considered in a receive model, like age and PS we have considered for the data equals to chemo, that is we have assigned the data set as chemo. Now the whole thing we are calling through as fit, and if we put the print of fit, then we will get the result. It is to be noted that there are 3 special terms that may be used in this model equation. A strata term identifies a strata Coxs model. Separate baseline hazard function are fit for each strata. The cluster term is used to compute a robust variance for the model. The term plus cluster within parenthesis ID, where each value of ID is unique is equivalent to specify the robust true argument. If the ID variable is not unique, it is assumed that it is identified cluster of the correlated observations. The robust estimate arises from many different arguments and thus has also had many labels. It is variously known as the Hoover sandwich estimator, while the estimate, that is linear model or economics, the Hurwitz-Thompson estimate is known well. The working independence variables, that is generalized estimating equation, the inference jackknife and the mean in West also estimate is useful here. The time transform term allow variable to vary dramatically from time to time. In this case, and the TT argument can also be useful to run with time transform term. So all these things we are not going to details in this module, but it is as much to check details the package of Coxs proportionals, that is library survival, for more details about the fitting of this Coxs proportional. Now we are showing the simple explanations in this module. Now we are going for print fit, and this output will be showing as Coxs formula of sub fu time and fu stat with age, PS and data equals to chemo. For coefficients age, it will be 0.0615 with exponential of coefficient, that is 1.06, and standard error of coefficient with 0.07, with z value, that is 0.80, having p value 0.42, with PS score, that is 0.69, and exponential of coefficient 2 with standard error 1.00, and z test value as 0.68 with p value 0.49. So it shows that none of these two factor covariate we have considered in this data as influencing towards the here. It shows that none of the variable we have considered here is in a positively or negatively associated with the status of these patients. However, the log live ratio test is given 0.29 and 2.96 with p value 0. However, the likelihood test value is giving as 2.96 with p value 0.228, having total number of individuals 27 and number of event 3. It shows the model is not significantly fitted here. Now we will go for next slide. Since we have considered factor like age and pH to fit the Coxs PH model, now we will that assign as fit. Now we will see ANOVA with fit, that is we want to check that group wise any difference is there or not, and that can be done by putting the ANOVA model on that. And to see that we will go for next output, and that's showing there the age wise no significant difference been observed, and performance score wise no significant difference is observed. For age it's coming 0.12 and PS is coming 0.43, where the log livelihood obviously coming minus negative, where the log livelihood obviously coming minus for age, that is minus 3.83, where log livelihood for age is coming minus 3.83, and where the log livelihood for age is coming minus 3.83, and for performance score it is coming minus 3.53. It shows that models are quite fit, but however they are not significantly associated on this survival of these patients. Unfortunately, in this partial data set we are having only 3 events, that is why it is very difficult to state that which group is having higher death and which group is having lower death. But I suppose in suitable example this factor like age and performance score can be can show us that they are really influencing on that event or not. Now we will go for next slide, that is plot survival fit, and that is having fit we had given with survival Coxs proportional hazard model, and X scale is given with 365 days, having X lab with years and Y lab with survival. This is the outputs given. Now we change the days of follow up into years by considering X scale equals to 365. Now this survival probability with this confidence interval is coming. The confidence intervals upper and lower is coming with the dash lines, and these point estimates of survival estimates is coming with the broader line. Here it is to be noted there are some censoring observation measured in this data set as well. Here as initial study initiation period, all of them were alive, so survival probability is coming near to 1, and seeing days passes here, so some of them died, and the survival probability keep on decrease here. Since it's a step functions around 0.2 years first step down from 1.0 to 0.96, and thereafter again around between 0.3 to 0.4 years again this second step down occurred. So some patient one patient died during that period, and third time it's happened between year 0.5 to 0.6. So it is to be noted that in this data set we have seen only 3 events, so 3 step down function is observed here, not more than that is observed, and also the lower confidence interval is going lower curve as a lower curve of these survival estimates, and upper curve as a going as a upper of these survival estimates. Now we are going for estimation using R, that is where we are assigning as model dot 1 with Coxs proportional as served a few time and a few step with factor called sex and age. So it's additive factor considered. We are not considering any interaction term between age and sex. We are simply calling sex and age contribution on their survivals. Now for that, once we have called the model, now next step is to call the calls. As a calls, we are using the function called data.frame. Into that we are asking age equals to 25 and sex equals to 1. So it's a assigning for specific individual having age 25 and sex is 0 coded. Now we want to estimate what is his survival predictions basically for that. So now again next step we are calling the summary functions. Into the summary function we are calling summary fit and model dot 1 that we obtain by application of function called Coxs PH in the first line. Thereafter we are calling the new data is having, that is Cobbs, and having the age of those patients having age 25 and sex as a female coded as 0. And now we are using the non-parametric estimate, that is ln, Lenzell ln. Now that estimate will give us those patients are having age 25 and they are belongs to female category, what will be the future estimated of lifetime or survival risks over the period. When they will be at time 19 days, what will be their estimated survival? That shows that 95% survival with confidence interval 0.08, 0.80 to upper interval 1. When they will be at time 22, then they will be having with risks 26 and one event will occur and the expected survival probability will be expected survival probability will be 0.90 like that. So this is the whole set of time period, estimated time period for this is the estimated survival time period given for all individuals. Though for the specific conditions they will having age 25 years and again sex for female. So that kind of prediction can be also obtained for other group, sex group like male also, and for other age group also. So this is the utility of these functions. Now we are considering, we are giving this result into a plot, and the same function is given here as Coxs PH with served a few time and a few status with age, and again plotting them to represent it graphically. And it says that those individuals will be having age 25 years, what will be their predicted survival rate over the period, and that is prediction for survival for a 24 years old using age. So here, since we are not considering in this data frame, you can see that plot of sub fit and fit new data equals to data dot frame age equals to 25. Since we are not conditioning other factors, so it will give irrespective of male and female all individuals, those are age 24, their prediction survival will be obtained. But in place of age 25, if you also included other factor like sex equals to 1, PS equals to something like 1 or 2, then irrespective of that condition we will get all these specific condition predictions. That is the beauty of this application of Coxs preposition and combination with sub-fit function. Now this is the output results given here. Those individual having age 25 years, those are treated with the treatment, what will can be the expected survival for those treatment irrespective of this treatment. Since here we are not stratified the data into one treatment or another treatment, so irrespective of treatment, this is the probability of survival, prediction probability of survival for those individuals who are having age 25 years exactly. And like it started again from 1 and it reached up to 0.0 at the end of 0.7 years, and the upper dashed lines is showing this upper confidence interval of this survival function, and lower line showing the lower confidence interval of this survival, it can be attractive choice to get the prediction for other age group people who are treated with different treatment also. I think we enjoyed this slide, and it will help you for future other stratified Cox proportional hazard and prediction for each individuals in this code. In this module, we have seen the application of R for Cox proportional modeling, and thereafter taking the inference after applying the Cox proportional modeling. The application of Cox proportional modeling should be through prediction of modeling and draw reliable inference using those model. In this module, we have considered a data set from chemotherapeutic trial to show each step of the process for conducting model building and selection of model, and thereafter statistical inference from that model. The same Cox proportional regression modeling using R can also be considered in other survival analysis data. The statistical inference, whatever we have seen here, that kind of statistical inference can also be considered in different research.